Hello.
Hey, Aaron.
Alrighty. Welcome, Andrew.
Hi. How are you?
Good. Your audio sounds good. Thanks for testing.
I'm not deafening everybody this time, am I?
Nope.
Not so far.
The levels are correct.
So I guess we have a 90-minute slot this morning that we don't expect to fully use, perhaps, in which case we can give people the traditional 2 or 3 minutes grace, I suppose.
Yeah, I think that's reasonable, especially given the difficulty in finding the URL.
Yep. Okay, I guess we're at 3 minutes past. Do you want to fire ahead, DKG?
Yeah, I think we should probably get started. Hopefully more people will come in, but it has been tricky to find the location for it for some reason. I don't know why. If you have the Zulip chat open, I've opened a bug report about it. If you've had trouble finding your way in here at the end of the meeting, maybe you want to go comment on that GitHub issue as well. That would be useful for them to know to prioritize this for other interims. So this is the February 2025 OpenPGP interim meeting. Thanks for being here. Steve, you want to advance the slides here?
Oh, that's me. Sorry, yep.
This is the note well, just a usual reminder. I think everybody here already knows this, but if not, please take a look at the details. This is about the intellectual property requirements of participating in the IETF and the various best practices for how we do our work. Make sure that you are aware of them. This is a remote meeting. Have your audio and video off unless you are the chair or you're presenting, or when you're speaking from the queue. You're going to enter the queue using the little hand button at the bottom of your screen in MeetEcho. If you're connecting, we recommend you use a headset. And there's a text chat also happening. It's on Zulip, but you can also see it in the MeetEcho window if you click the little overlapping word balloons at the top left. So if you haven't used it before, please make sure you're available. You have access to both the chat and the queue. Next slide. Right, so this is the code of conduct. It's a reminder that we are here to talk about the technical details of these specifications. Please communicate clearly and discuss the concerns you have using argument rather than a personal attack. And we're looking for the best solution for the whole internet if we can, not any particular vendor. So thanks for participating and following these guidelines. It makes the conversation easier. Let's, unless anybody has any other business to add, I think we can probably move on to the first topic, which is the post-quantum crypto work. I believe, Aaron, you're presenting this. Does anybody have any other thing they want to raise before we start the post-quantum crypto section of today's meeting?
So just one note, so Stavros has been kind enough to volunteer to take some notes for us, so thanks, Stavros. If somebody is able to help out in the note-taking tool, that would be appreciated. There's no need for blow-by-blow verbatim notes, just kind of actions and things agreed are the important things to try and capture, Stavros. So we don't need you to kind of track all the conversation because it's recorded anyway. So.
And anything that's in the slides has already been, in the slides. So yeah, we need the things that come up in the notes.
So not hearing any agenda bashing.
And Stavros, when you need to leave, just give us a wave in the chat or pop on voice and say I need to head out, just so we know. Because if nobody else has stepped up and volunteered, we'll know that something needs to be done about the note taking.
Yeah. Okay. I will.
Thank you, Stavros.
Okay, Aaron, you should be getting slide control.
Yep. I see it, yeah.
Great.
So, hi, and welcome to another PQC draft update. What we will be looking at today are the changes between Strat 6 to 7 that we just published a few days ago. Most of these changes were discussed at the IETF 121. Namely, the assigning the code points for the ML for all the signature algorithms that we already had in the draft. We aligned the CAM combiner with the LAMPS construction, and these automatically also dropped the CCA conversion for X5519 or X448. Another small change is we decided to switch to the SLHDSA hedge variant. That seems to be the default in most libraries, effectively not many libraries even offer other variant. And also it is more secure against side channel attacks. Then there has been an update regarding the seed key format that we had chosen at the last IETF. That is PKCS 11 technical committee just decided to allow both formats. So hardware manufacturers will be allowed to store the secret key both as expanded and as seed format. So this caused LAMPS to change their mind and so far, or apparently, decided to allow both seed and expanded format. There are some HSMs out there that allow key exporting. Not all of them do, but the ones who do and the ones who use the expanded format won't be able to export to OpenPGP wire format if we decide to keep on going as we are right now. So we, for now, decided to keep the seed format for multiple reasons. The major one is the fact that in OpenPGP, exporting from an HSM, a key that is generated on it, is a bit of an edge case. And we believe that in this case, it should be re-imported onto another HSM in case you want to make a backup or something like this, and should not be then used in software, at least not necessarily. And the other reason is that we want to reduce complexity. We don't want to offer a protocol that has two different formats to store the private key. And generally, from the seed key format, you can always obtain the expanded format, but the inverse is not true. So if you look at importing a key into if you want to import a key into hardware, that is instead a much more common operation in OpenPGP, at least to my knowledge. You can always do that because you can compute expanded format, but you might have trouble exporting a key from hardware. Then the advantage that we also pointed out last time, that or generally smaller keys, the libraries we're using prefer the seed format, and they always produce a valid key. Yeah, so that was all about the seed key format. Please let us know if you disagree on our decision, or if you would like, or if you have any concern with it. Then another topic is the key derivation. Oh, okay, Stephen, should we do a queue now for questions about this, or should we keep it for the end?
Well, up to you. Whatever you.
Let's do it now. Let's do it now. I think because the next topic is completely different. So
right.
let's.
So my question was just, lamps are thrashing around on this topic. Even if the seed is likely fine for OpenPGP, is there a scenario where lamps or lands on a decision that causes APIs to not be suitable for OpenPGP? I mean, it's not clear to me.
I can't really imagine a scenario where lamps, like where we would, I mean, because by supporting both the libraries that we also may share with lamps, we'll need to support both.
Okay, so yeah, I mean, I've been watching all those emails on the lamps list go by and not reading most of them because like there's too many. But okay, so we're happy that the API participants in that discussion are still supporting seed. There's nobody saying I only want to support expanded.
Yeah, so far this doesn't seem to be.
Okay,
Yeah.
That was my question. Thanks.
Okay.
Okay. Any other question? If not, close the queue and go to the next topic. Okay, doesn't seem like. So CAM combiner, this is a hot topic in our draft. I think we changed so many of them already. We updated it, hopefully, for the last time. We aligned it to lamps, as we discussed at the last IETF. It's basically the same. It just contains a little bit more additional data. These additional data are the ciphertexts. So we followed the kitchen sink construction that you can find in the IETF personal draft data. And this means is the construction that contains everything and has a secure, let's say, fairly simple security proof. This also gets us FIPS compliance from both NIST SP800 56C, as we discussed at last ATF. The previous construction didn't, and also the new standard SP800 227. So if like SP856C actually limits it to be the NIST compliant algorithm, be the first one, while instead the second expand this concept also to the latter, to the second or like second CAM in the combiner. In our case, X25519, X448 are not like NIST compliant, and most likely they won't be. So 56C for this draft will suffice. But to reuse the same construction also in the NIST draft, then it might be useful to have SP800 227 compliance as well. This is how it looks like. It is a SHA-3 256, so nothing fancy, no more KMAC, of a concatenation of all the data that is on the wire. So key shares, the secret, the two secrets, the ciphertext, the public keys. There is an algorithm ID and a domain separation that is OpenPGP specific, in order also to separate from apps. So far, we have implemented all three. I mean, these are not three algorithms, but three algorithm families in all three libraries that we were working on. We have test vectors, they are interoperable, and they actually, this table looks very nicely green, unlike last time where we still had SLH DSA not compatible for both GoCrypto and OpenPGP.js. In the latest version of the draft, there is also test vector for SLH DSA, and we invite you, if you're implementing it, to just try it out and, well, let us know any feedback on that. This, I copied it from the last time. We managed to close all the open issues and all the pull requests we had raised since the last IETF, and we are happy to ask you if there's anything else we can do before we go last call, or if you're fine with the current state of the draft. Thank you. If you have any questions about the whole slides or the draft, we're here to answer. Okay, Justus?
So, sorry about that. I noticed that section 8.1 veers into trust model and key selection. And I don't like that too much because we are starting to discuss notably key selection in various drafts. And we are doing that before even having a discussion about what we want from that, right? So, I mean, yours is okay-ish because it only contains shoulds. But for example, it kind of suggests that there is a single PQT subkey that should be used. And that seems to preclude the use of HSMs.
What you mean that we okay, I see what you mean. I mean the fact that we say if there's a PQC key, please use the PQC subkey to encrypt, and
Right.
don't encrypt to all the subkeys / don't encrypt to all the keys.
Right. Also, there is this vague notion of knowing that the classical certificate shouldn't be used, and that seems to go to trust model territory.
So, indeed, the reason why we state that is simply because if you encrypt to both classical and post-quantum, well, you lose the effectiveness of post-quantum effect. Like, while a double signature is fine, a double encryption is as strong as the weakest link in the chain.
Right. Yeah, and
So,
I mean, I understand the desire to make it more and more secure, but that seems to lose track of maybe other factors like ergonomics. So I'm worried, and I'm a bit sad that we are starting these kind of discussions and adding this kind of recommendations to our texts without having a proper discourse on the implications of that. You know, we can make it more and more and more secure, but it's not clear that this really results in people
what's
being
the
more
use
secure.
case that you would imagine where you have to encrypt to all the subkeys in a key?
Well, HSMs, like non-movable HSMs. Like I have an HSM in my laptop and I have an HSM in my desktop computer.
So
if I want to,
how would you signal to the sender that you want an email encrypted to both subkeys and not just one?
I mean, I personally would add a per device encryption subkey.
Yeah, okay, but if you have two subkeys that both encrypt, and one is the old one and one is the new one, and you want just how.
I mean, that's my point exactly. You seem to assume out of nowhere that, the creation timestamp signals some kind of preference, and it's not clear to me that this is the case. I mean, I don't want to stall that.
In this case, it's not the creation subkey, because we say prefer the post-quantum no matter what. Like, if they both have a valid binding signature, clearly, if both valid subkeys, prefer like prefer that one. But in case if you generate a key that has a PQ subkey and a non-PQ subkey, because you still have an HSM that doesn't support PQ, or then you still have that issue. Like you still, why do you even bother with PQ? Point, right? That's my question. But I see there are more people in the queue. Are they about this topic or are they new?
Yes, I wanted to jump in on this topic indeed, because I mean, we had similar discussions before, right? And I kind of agree that they are orthogonal to PQC mostly.
Mhm.
So I mean, I also agree, of course, that if you encrypt something with both a PQC key and a classical key, then you don't get post-quantum security. But there might be other cases where you might need to do that if you are sending to multiple recipients, perhaps. So I kind of agree that maybe we should consider it out of scope for the PQC draft and just say something like, if you encrypt something with both a PQC and a non-PQC key, then obviously you don't get post-quantum security. But other than that, we don't make any normative requirements about it. And then we postpone the discussion about whether to use multiple subkeys or one subkey to like a separate document or a separate consideration, because that's like, I mean, like that seems to be a very large topic in itself, right?
Mm-hmm.
So I agree that this topic seems to be orthogonal to both the post-quantum work and the key replacement work, but saying that, you know, we're gonna talk about that later, and meanwhile we are gonna entrench our the status quo in the text we produce seems to be not ideal to me.
Yeah, so I mean, I'm agreeing I think with you that then we should change the text to like not say anything about it, right?
Mm-hmm. As of now, it's a should, if I recall correctly. So we say you should encrypt with the PQ key. It's not a must, and if you have a good reason, we may drop that to a may, or we might even completely. I mean, as of now, I think there is already the mention that if you encrypt to a post-quantum and non-post-quantum key at the same time, you lose post-quantum security. That's no matter what. That's a fact. If we want, we can make either open an issue or make a PR to the text, and I think we can discuss it then on the list, because it should be, as Andrew says, we should make the implementations aware of this, but I don't think there's, if you think there's no good reason to restrict, I have no problem with this being handled, let's say, differently.
Yeah, maybe if I can add something to this discussion, if I remember correctly, this is a long time ago. I think the motivation was to give some kind of a selection strategy there to give implementers a little bit of orientation, how to do some kind of a smooth transition. And Daniel, we already have this comment that, you know, if there's one key that is not PQ capable, then you have no post-quantum protection there. So just for the notes, shall I just note that we drop selection strategies and maybe just state some facts, and we will open an issue for that? This is.
Yeah, I personally think that makes sense also because, I mean, I think the original justification also makes sense, but since we now also have the key replacement draft from Andrew that says more about how to select which key to use.
Okay.
And I mean, and more discussions to be had later, right? I think it makes sense to, yeah, keep it at that.
Yeah, that was not present back then. And in the project, we made some approaches to how should maybe Thunderbird look like when you have this user dialogue, how to choose PQ keys, and we had then two selections there saying backwards compatible and not backwards compatible. This was a little bit the background when we thought about what are possible migration strategies. But okay, I will note that. Thank you.
Okay. Thank you for the input. And we'll move this down to the issues/PRs/list. Any other remark?
I was just hoping that somebody who is involved in this discussion that we just had would be up for making a PR, volunteering here to make a PR shortly, just so we have two pieces of concrete text to compare.
I mean, I would say that either once we have an issue that states exactly the problem in writing, as authors, we can also make a PR, or if Justus, you feel like making one, go directly for it, as you wish.
So I guess in the notes we're saying that Aaron is volunteering Justus to make the PR, but
no, I mean I'm saying so. I mean it's either you make directly a PR or you make a clear statement in an issue, and then we can work a PR out of that. It's like, for me, it's no problem as long as we have a place to start from.
Okay, well, I will make an issue at the very least, stating my understanding of the discussion.
Okay.
And hopefully folks can weigh in on that. But after this meeting, I'll make an issue. So I'll commit to that. Thank you.
Okay.
Thanks for the discussion.
Thank you. Okay, then I guess. Oh,
so just a chair-like question then. I mean, I think that's a discussion that could well be had during a working group last call. Does anybody feel that we should or should not start a working group last call? Obviously, the authors would like us to start a working group last call. Does anybody want to argue that we should not do that until X, Y, or Z has happened? Whatever, for some X, Y, or Z. Or is everybody kind of okay that we start a working group last call and discuss that issue plus whatever else happens from people reading the thing? And I'm going to interpret silence as people saying it's okay to go ahead and start a working group last call. DKG, does that sound right with you, or?
It sounds right to me. I think we're ready.
Okay, and if depending what that throws up, there could be a second or a third working group last call. Who the hell knows? But hopefully not. But okay, so we'll let the notes of this meeting percolate out, and then kick that off in, I don't know, a week or so.
Sounds good.
Okay, cool. That's probably one for the notes.
Thank you.
And we'll try to remember to do that.
Yep. There's one more slide here, Aaron. Did you want to go to the page 10 of 10? Okay.
In case you want to raise issues, we still have an issue tracker, and you can check the latest version of our draft.
Great. Thank you, Aaron. Andrew, you're up next. Do you want to ask for slide control?
Sure. There we go. Yep.
Right.
Yep, I have control. Thanks very much. Okay, so quick update on the key replacement. This should be fairly short. So the only really substantial changes since the previous are that we've now changed the format of the target slightly. So we have now agreed, I hope, that we are including the fingerprint and the imprint in all cases. even when they are the same. There's a slight there's a slight duplication of information, but it does make the parsing simpler and easier to reason over. Pretty much everything else is the same as the last time around, so I'm not going to go through it all. The recent changes are just the no replacement bit is now effectively deprecated because it duplicates the reason for revocation. So we merged the semantics of the two. Preferred key server subpacket is now no longer mentioned, and a few bits and pieces regarding treatment of undefined bits and UX guidance and so on. The big outstanding question that we still have comes from a question raised by Johannes a few weeks ago, which is the idea that it may be useful to make fallback encryption optional. Now, there has been one more issue raised in the last day, and unfortunately it didn't make it into these slides. I will come back to that later. The basic idea behind the optional fallback encryption is that having an equivalence binding means two things at the moment. It means that you can fail over seamlessly from the original to the replacement, but it also means that you can fail over seamlessly from the replacement to the original if you do not support the algorithm choices on offer in the preferred replacement key. Now, a key holder may not wish to have this fallback, and there are a couple of scenarios where this might be applicable. One of them would be that they have lost the secret key material for the fallback key and are no longer able to revoke it or expire it. So it might be useful to be able to specify on the inverse replacement key subpacket in the replacement certificate that fallback should or should not happen to any particular original. There are two ways that we could do this. We could just do it globally in the class octet, which basically means no fallback to any of the originals where there is more than one original, or we could put it into a target specific flag, which allows more granular control. So there's a link there to the ticket, which contains a good deal of discussion. So the pros of this is, as I said, it allows much more granular semantic control. It also does mean that if you do have an original certificate that you don't want your correspondence to fall back to, they don't have to refresh it in order to find out that it's unusable. You can mark it as unusable in the replacement certificate, and there's a single source of information there. The disadvantages are that it's not quite clear how often this would be used. So I have mentioned that the standard use case for this would be if somebody lost their private key material of the original. If we want to make it per target, that means another wire format change the target record. The way that flags tend to be done in OpenPGP is that we just specify an unlimited length field that runs to the end of the subpacket, and if the subpacket is truncated, then the bits are unset. We could, if we wish, also specify that this is allowed in a target record, but just not specify any bits and leave it open to future expansion. But again, this is all getting into much more complex territory. So we have 3.5 options to proceed with this. The zero option, which is the null hypothesis, is just leave things as they are. Fallback is possible if an equivalence binding exists, and there's no change effectively to the draft, except maybe some wording cleanup if necessary. Option 1 would be per target flags. So we allow a flag octet at the end of each target record, and if the first bit of that is set, then that changes the fallback behavior for that particular target. I have written this up as MR17 in the repo. You can have a look at it if you want. The link will be at the end in the last slide. The other option, which doesn't require a wire format change, would be to specify another bit in the existing class octet, which would apply to all targets. Similar semantic meaning, but no wire format change, and it would only apply then to every fallback key if more than one is set. And then, as I mentioned, if we don't choose option 1, we may also wish to allow per target flags. I suspect we won't choose this, but I've put it in just for completeness. Before I move on, I just raised the issue that Neil mentioned yesterday, which is that there may be another way of doing, essentially doing key equivalence, which would be to have the secret key material of the primary key shared between the original and the replacement, and that key equivalence is inferred from the fact that the key material is obviously the same. There's been a good bit of back and forth on the mailing list even up until a few minutes ago. So I think I'm up to date to all of it. I don't, there's no mention in these slides. It came too late for the slide deck. My current gut feeling is that it's a neat idea. I think its applicability is restricted because again, it's only going to be useful where your key material is for an algorithm that is usable in both the old and new keys. It's only useful if you have different key versions. And it also, I don't think it generalizes well beyond the v4, v6 transition. Like if there are certain key material packets where you could theoretically have a v4, a v6, a v7, a v3 version of version of a key with exactly the same key material, and how to generalize this beyond the simple v4 to v6 transition is unclear to me. So while I think it's a neat idea, it's definitely it's a very clever trick, and it may be useful. I'm not convinced that it is general purpose enough, and maybe we've already made this too complicated. So I'm going to throw it open at the moment to the floor if anybody wants to speak. I think Johannes is on the call. Maybe if I've misrepresented your opinion, please feel free to speak up at this point. Johannes. Go ahead.
Oh, sorry. Yeah, it's all fine. So it was represented perfectly.
Okay. So does anybody else have a particular opinion on this? Has Daniel?
Yeah, I mean, I can restate my opinion that I sent to the list, which is that for this for the fallback encryption flag, I think that indeed in most cases it shouldn't really be necessary, or at least like it's a very specific scenario where it's useful, right? And if you don't have the old key material anymore, ideally you should find some, I mean, we should find some way to revoke that key, either with a revocation certificate, or ideally, or perhaps you could assign a designated revoker or delegated revoker, whatever it's called, revocation key, if we sort of revive that idea. Like this seems like a very specialized subset of that somehow. Like if you have a replacement key and then you want to say, okay, don't use the old one to encrypt, but it's not revoked somehow. I mean, if you don't have the key material anymore, we should just find a way to revoke it, right? And then it seems kind of orthogonal from this draft almost.
So yes, one thing that you mentioned there, which I think might well cover this use case, is the designated revoker. Now, we've deprecated designated revoker in favor of still in draft work in progress mechanism. So I'm not sure how useful it would be to implementations right now to say, when you set a replacement key, you should also set a designated revoker. Like that, if that was available and well supported, I think that would be a very good mechanism for doing this.
Yeah. I mean,
unfortunately, it's not.
Maybe the more practical advice right now is just to store a revocation certificate somewhere, right?
That's already good advice anyway, but we know that people do lose their revocation certificates. It happens. If you lose your secret key material, you can lose your revocation certificate as well. So it's not a foolproof method. Daniel, the other Daniel.
Yeah, thanks. With no hats on, I just wanted to, I'm leaning in the direction that I think Daniel was also leaning in that this seems like it's additional complexity. It covers one narrow use case. We have other solutions for that use case, which granted are not perfect, but that's actually okay. This wouldn't be perfect either, because maybe you haven't mentioned that you have another key. And I think if we want to tackle questions about how you effectively revoke, I think we should tackle that separately. There is a revocation draft. It's under my name, but I'm happy to have anybody else take it over if the working group is interested in adopting it. I don't think we do ourselves much favor by trying to shoehorn a discussion of revocation into this draft when we could just get this draft out the door if we wanted to. That's my preference, but that's with no hats on.
Yeah, I'm definitely not suggesting that we specify revocation mechanisms here. Absolutely not. I'm just
saying that this smells like a revocation mechanism, right? It's like a half revocation mechanism. If you're able to get to this thing, then you can say don't go back. But it seems very similar to revocation, and I'm worried that I want something that's this simple, that works for the PQC transition and works for the V4 V6 transition. And I don't want this to be delayed because we get into the whole discussion about the semantics revocation, which turns out to be more complicated than, when I started writing the revocation draft, I was like, oh, I'll just knock this out. And then I was like, oh, there's a bunch of nuance in here to figure out.
Yeah.
And I don't know that we want to open the door to that in this draft, but that's my intuition here. Maybe I'm too conservative.
No, I hear you. Anybody else want to join the queue? Nobody right now. Okay, so the other thing that is sort of related to this is Neil's idea about key equivalence through key reuse. I think it's probably too soon to have a discussion about it now. So I think we need to maybe punt that back to the list and come back to it again. There's obviously some more discussion to be had with that. From even for this particular issue at hand, though, is it the feeling of the group that we stick with option 0, the no change option? Is it worth a show of hands at this point, or do we want to include something about this in the draft, even without a specific mechanism at this point?
Over in the chat, Stephen suggests that this might not be a great meeting to make a decision. Stephen, are you saying that about Neil's proposal or about this?
More about Neil's proposal.
Got it.
Yeah.
So Stephen, would you be open for us doing a show of hands on? I'm not sure how you'd want to split this up. You have 4 lovely options here, and our show of hands tool is a binary thing. I don't know.
I would. Justus, sorry, go first.
So I want to come back to key selection, and I'm not sure if this is the moment, but I feel like what you're discussing is a way to further restrict key selection.
Yes, in a sense, yeah, it is, yeah.
And I feel like I made a proposal on how to make key selection explicit, and that proposal could be used to restrict key selection. And I'm a bit fuzzy whether this is reflected in one of your options listed here.
So it's not reflected in one of these options. However, option 3 could potentially be extended to include your proposal, if the group so wished.
Then I would like to request not to make a decision now, but consider key selection first.
Okay.
So at any rate, we're not going to make a decision now. The decisions are going to happen on the mailing list.
No, there will be no decision now. But I would like to get the feel of the room, because there have been a few people speaking, but we have another 9 or 10 people on the call, and I'm not sure how to read the silence. That's basically my issue here. Do we just want to defer this? Maybe that's the first question.
So Andrew, if you have 4 options here, if you're just looking to eliminate some, we could just run a show of hands for each of them, and then you can take what information you can glean from that.
Yeah,
so
sure.
Each of these options, we could ask people to say, do you hate it or love it, and approximate a yes or no, and that would give. Is that useful input?
That would be any input at this point would be useful. That'd be great, Stephen. Yeah. So for each of the options, yes or no, or abstain if you have no strong opinion either way. It would give us some idea how to move forward.
Okay, so as chair, as someone who's run these polls before, just saying yes or no is usually not a great way to elicit a meaningful answer, because yes or no could mean I would be willing to live with it, yes, or would it mean this is my preference? So I'm going to try to be a little bit more specific here.
Okay.
Your initial question was, should we defer this, meaning this whole discussion, I think? So
yeah.
So what if we just phrase the question as like 0 versus the others here?
Mm-hmm.
So
sure.
Would you prefer that we indicate that this mechanism allows indicating no fallback, some form of no fallback. And if you say yes, that means you would prefer 1, 2, or 3 over 0. And if you say no, it means you prefer 0 over 1, 2, or 3. Yeah.
Yes. So yes for change the current draft, and no for do not change the current draft.
And where we're just providing input, we're not trying to decide. So
no decision, just
directions.
straw poll, finger in the air. Yeah.
Great. Okay, DKG, if you can.
So it says, would you prefer replacement key allows a statement of no fallback? Sorry for the anguished English there. So if you think that 1, 2, or 3 is superior to 0, you should be pressing yes. And if you think that 0 is preferable to 1, 2, or 3, you should be pressing no. It looks like almost everybody who's here has. We've got 12 people in the room, and we have 9 people voting, 10 people voting, and it is about as neck and neck as you can get with these numbers.
And I think Taro is only on Zulip, so probably not taking part. So and Andrew didn't either, I guess, right? So
and yeah. I didn't vote.
So that's I suspect that's hugely directional input for you.
The answer is
no answer.
Yeah. So we are definitely going to need to take this to the list.
Yeah. Yeah. That is fair enough. More discussion required. Okay. Okay. Well, in that case, I'll just move on to the minor. And this is just the usual question I put in: is the terminology clear? Are we happy with the wording? Does it need further clarification in any places? This is just an open question, and it's going to stay open until the whole thing is closed. For the timeline, I think I was slightly optimistic here. I said 2 weeks, new draft with outstanding questions addressed. I think the last poll has put the kibosh on this timeline. I think it'll probably be more than 2 weeks at this rate before we get our now 2 outstanding questions thrashed out. So please, everybody, have a look at the mailing list, catch up on today's messages if you haven't, and have a look at the repo, which is here on screen, in particular the OpenMR, and also Justus's open issue as well about encryption selection, since it seems to keep cropping up. And we will talk again. Thanks, everybody. Any further questions?
There's a question in the chat from Stephen about implementation. Justus, do you want to speak first? Okay, he's dropped out of the queue. So do we have implementers? Do we have a way to test?
We don't currently have any test artifacts. I know that Johannes and Falco were working on implementations. I'm not sure if I'm not sure if Proton are working on an implementation right now. I'm not aware of it, but please correct me.
We are not at the moment, but yeah, I don't want to make any promises, but I think the draft seems reasonable to me.
Thanks. And I know Justus has already expressed concerns and is not currently working on it in Sequoia. So, Justus?
I mean, are we starting the discussion, or are we still in the?
We're just talking about implementation. I mean, you've said yourself that you weren't working on an implementation.
No.
Okay.
But I think it's fine for discussion. We're here at the meeting to discuss. So It's just if you have comments you want to weigh in on, please weigh in.
Okay, so first of all, I think it's highly unfortunate that we started working on this before having a conversation about trust models, because this draft is all about trust models. It talks about the equivalence between two certificates and what that entails. And we are building that on a shoddy foundation. And I also think that this will be challenging to implement for implementations, because it's my understanding that not many OpenPGP implementations have strong support for trust models. So I guess they will need to build a lot of foundational support first. Like, it's not enough to hand in one certificate. You have to reason about a couple of certificates suddenly. Second, let me get my notes. I found section 5.2 odd, because it seems to imply that WKD is somehow trusted. Also, it uses the word trusted, which I don't like. And the whole sentence is kind of odd. I don't understand it. And then section 6 talks about key selection, which again seems to prioritize security over anything else, notably over ergonomics. And I think this is a rather unfortunate thing we see every now and then, or often in our circles. And this is something the AutoCrypt project got right, I think, whereas they focus on not breaking user experience, not making mail unusable. And the problem I see with this draft in particular, I mean, it's hard to know what people want or need, but if I consider my own needs, if I were to use this mechanism today and my peers had an implementation that acted like described in section 6, I would immediately get unencryptable emails. So this mechanism doesn't work for me. And so I'm having a hard time picturing it working well for others. And this comes down to the encryption subkey selection. And I feel like if that were to be made more explicit, like I think I suggested, then this would not only make it work for me, but it would also solve the no encryption thing that you just mentioned.
Sure. Daniel?
Yes, so I agree that like it would be good to solve the encryption subkey selection question, right? And but I think that in some way it is still orthogonal as well, because so my understanding of this draft, or how I would interpret it is that it is to say that instead of adding a subkey to an existing key, you can also add a primary key to it in some sense, right? And which then also has subkeys, and then you treat them kind of sort of like they are subkeys of the original key in some sense. And then you can have an object that consists of multiple transferable public keys, and use it to encrypt a message, and then like you can treat it as if it was one in some sense. And then you can like if you want to pick one subkey, you can pick one subkey out of both certificates, or if you want to pick all of them, you can pick all of them. Even though, I mean, it, like, in some sense, it kind of makes the problem worse, maybe, since, like, then, I mean, we're extending the incompatibility somehow. But it's in a way an orthogonal question, right?
Justus?
I agree, it's orthogonal, and I wish that we had discussed it first. And I also agree with Daniel's picture of having a tree. In fact, we call that a tree certificate. And maybe stepping back further, I think it's unfortunate that we never really had a discussion on what we think OpenPGP is, or what we want from it, or what its strengths are. But personally, for me, OpenPGP makes the user sovereign, and it empowers her to make decisions. And that theme, I think, making the encryption subkey selection explicit fits really well. And I think that also helps with having incompatible or implementations that react surprisingly, because you just make it explicit.
Okay. So look, Daniel, sorry, is in the queue now as well.
Hi, this is also with no hats on, just as an implementer and as someone who supports people who are using these tools. I just wanted to sort of comment on I think there's two things that have been brought up in the last several minutes of discussion, and I want to separate them out, and I want to say why I think that maybe those are separate topics, and maybe they aren't relevant here. So one question is about subkey selection. I agree, this draft does not necessarily answer that question, and maybe if there's places where it is hinting at a specific answer that it wants, maybe we should just rip those out, because I agree that subkey selection is contentious. It's contentious also, like the proposal for the additional decryption subkey packet in LibrePGP clearly is trying to address the same issue. Whether it's doing it right or not, I don't know, but maybe that's something that we want to talk about as a distinct thing. I think Daniel's point that what we're saying here is this equivalence class that gives you more keys to choose, subkeys to choose from if you're looking for some subkey for a given user. Similarly, I hear Justus's concern that we have never really tried to tackle what does the trust model actually mean. But I'm not sure that the order to do that in is to try to tackle the general topic of trust models. And one of the things that I really appreciate about this draft is that it doesn't tackle trust models. Instead, all it does is it introduces the idea of the equivalence of two OpenPGP certificates and lets the user put together, or the implementation put together, whatever it believes about trust models, and says, if whatever you think about trust models, these two keys belong to the same key holder. And they are stating that they belong to the same key holder, and you can make of that what you will with whatever trust model you happen to have. And I think in some sense that is a building block for talking about trust models, as opposed to something that needs a discussion about trust models to do this. I think it's useful because this draft is basically providing one specific primitive in a much woollier landscape. So that's just to be clear about where I think this is. I think if this draft keeps to that particular lane, I think that's a useful contribution, and maybe something that we can get people to agree on. And to the extent that the draft spreads out into assuming things about how people's trust models work, I think maybe we can sort of prune that back to keep this draft in a narrow lane that we can actually wrap and produce. I will also say that, I'm going to keep banging the tests drum. The more that we have a clear vision about how to know that people are doing this the same way, the easier it will be to tell if this is something that is desirable. So test vectors, test vectors, test vectors.
Yeah, I on the issue of test vectors, I think because there have been so many open questions about the wire format, it felt premature to create a test vector. I think if we can tie down the last question there about the target specific flag octet, whether we want it or not, then we can now start making test vectors. I think at that point, once we're reasonably sure that the wire format is finalized. About the other question about the trust model, what I have tried to do in the draft is keep it as agnostic as possible regarding broader questions of trust models, precisely because I know it's a can of worms, and I neither want to start nailing down a specific trust model in this, nor do I want to invalidate somebody's existing trust model in practice. And I was hoping that the wording that was currently in it was sufficient for that. If it is not, please let me know. That goes back to slide 8, which is the draft terminology clear? If we think sections 5 and 6 are not sufficiently clear, then yeah, let's clean them up. Definitely. If there's a use of trust in there that is ambiguous, then yes, absolutely. Let's clean that up. In terms of the scope of the draft, we've been talking about this for a while, and I think I'm definitely agreeing with DKG here about keeping the scope to its current extent and trying not to expand into the general question of sub-key selection or trust models, which I do agree we absolutely do need to tackle sooner rather than later. I just don't think this is the document to tackle them in. Otherwise, I'm definitely very much in favor of opening those discussions ASAP, because there is a lot of ambiguity in implementations, between inconsistencies between implementations. So, and this could drag on forever if we expand the scope any further. That's one thing that I'd be really worried about. We've run on quite a bit here, so I'd like to wrap up unless there are any urgent questions about the current wording of the draft. Justus, let's take your 2 issues that you mentioned over to the issue tracker, and we'll hash out something. Hopefully in the next few days, if that's possible. I don't know. I see Neil is in the chat. I don't know. Do you want to say anything about your recent proposal, or will we leave that for the mailing list?
I think we should move on because we have 20 minutes left in the session, and we've got one more presentation from Daniel.
Okay, let's move on. Thank you, everybody.
Stavros, you want last word here?
Yeah, so I will have to run as I have childcare duties. If someone else could take on, and people, please take a look if I reasonably have taken adequate notes. Thank you.
Stavros, thank you for taking notes. I'm not hearing other volunteers here on the note taking. I will try to take
I'll do it.
over. Oh,
I'll do
great.
it.
Thank you, Andrew. Appreciate it. Stephen, can you share the slides for, or yeah, can you grant Daniel this slide sharing? I think you want to give him the other slides, Stephen. Otherwise, we're playing PowerPoint karaoke.
Yes, thank you. Yes, so I will kind of share the changes to the persistence metric keys draft since last time we discussed it, which is not the same as since the last draft, because that was a long time ago. Sorry about that. And yeah, I mean, I already presented most of the changes that ended up in the most recent drafts in the last meeting, so I won't repeat all of that. Yeah, so the changes that I made based on the feedback from the last meeting were: one, I reduced the number of reserved algorithm IDs for future symmetric algorithms. Originally, I proposed to declare that the first bit in the algorithm ID says whether it's symmetric or not, which is like, you know, very simple way to do it, but it does reserve half of the algorithm IDs for symmetric algorithms, which is admittedly, you know, fairly overkill since we won't need that many. So this draft reduces that number. And then the other thing I did on GitLab, but not yet in the latest draft because I forgot about it until I read the notes from last time, is I restricted the use of persistence metric keys to version 6 or later keys, since there should be, as far as I can tell, indeed no real reason to use it with v4 keys, as Eustace pointed out last meeting, I think. So yeah, that's all for the changes. So this is the table in the latest draft with the proposed algorithms. So there's one. So there's still AAD and HMAX, same as before. And there's one block of reserved future algorithms and one block of private / experimental algorithms. I mean, yeah, let me know if you think this is still too many, but I think, I mean, there's quite a lot of free space in the algorithm ID registry. So I don't know, if we end up needing them, we can always change this again. But yeah, this is the current draft. Yes.
I have a tiny wish, maybe. The OpenPGP octet space is frustratingly decimal based, and maybe we can pick, or you could pick buckets of 16, so that we can have nice powers of 2 that it's easy to match on.
Right. Yeah, that makes sense. I mean, the issue is we already have 100 to 110 for the private / algorithm experimental.
That's true, but we could kind of fix that by saying it's the bucket starting at 96 to 112.
I see. Okay. Yeah, same. I mean, yeah, I can do that. Although, yeah, I mean, it seems like that's something that we should then change for all the existing algorithm IDs, right? I mean, yeah, I guess we can do that. Yeah, Andrew?
Yeah, just we've already run into issues previously with the private experimental range not being big enough when we were talking about post-quantum algorithms. So I think I think maybe this is something that's best tackled elsewhere. Maybe finding a way to expand the private experimental range. So maybe we want to just allocate another range entirely somewhere else, but it's worth revisiting.
Yeah, I mean, I can try to align it to something that could be expanded to a nice 16 block of algorithm IDs, at least. But yeah, I'll try to puzzle around and see if I can find something nicer. All right, then the one thing I didn't address since last meeting was the question about whether it should be possible to derive the public key material from the private key material, mainly because I thought that in cases where that's needed, perhaps we could just suggest that the public key material be stored together with the secret key material. In a way, since all of this, both of these algorithms will only ever be used with private key packets. All right, since the public key is useless. So the public key material listed here is really only describing what you use to compute the fingerprint in some sense. So like in principle, when you're storing the private key, you can just store everything. And then obviously it's possible to compute the public key material from that. And the same thing I think is necessary in some existing algorithms as well, including ECDH and ECDSA. So, I mean, yeah, hopefully that seems reasonable. But yeah, obviously, let me know if you disagree.
If I may quickly, so you mentioned the parameters for the ECDH key, and that is precisely what led to a problem. If you have the key material on a smart card and you want to kind of import that, then there's no place to store this additional metadata. And I worry that the same can happen here. So I don't know if there is hardware support for this kind of operations that we would need. But if there is, and there is no place to store the additional key material, then that could lead to the same problem.
Yeah, that makes sense. Though if the space is restricted, like the way this table was before is to have a fingerprint seed in the secret key material and then a hash of the seed in the public key material, right? So it was basically just moving the seed around. So I guess it makes it a little bit more explicit that if you're going to store a private key, you need to make space for that, I suppose. But maybe we could add some text saying that, because I mean, if there's no space on the smart card, then like also storing a fingerprint seed is going to be difficult, right?
Yeah.
In the OpenPGP external secrets draft, which is an attempt to specify specifically how you indicate that your secret key material is stored on a hardware back token or something, HSM, TPM, whatever you want to call it. The one invariant there is the assumption that from scanning your available hardware tokens, you can find the key that you want based on the public key material. So that's a different direction, right? So the expectation is, given the public key material, can I find the thing that matches it in the secret in whatever my bank of hardware available tokens are? And I think that's generally been the case with, I mean, it doesn't mean it's well indexed, but certainly you can enumerate what public keys are associated with a given smart card for proper asymmetric keys. And I just wonder if we want to think a little bit, I mean, how we want whether we want that linkage to be bidirectional. I tend to think that there's a lot of code out there that does assume that there is this bidirectional mapping. And it worries me a little bit about what'll happen to those chunks of code when they can't find that. But, you know, people can also implement and say, I got stuck or I didn't get stuck. That would be a good answer from my point of view. If somebody says, I can't use it this way, but I haven't heard anybody say that.
I think practically speaking, the answer is going to be the same, right? In order to be able to do that, you need to store the public key material together with the secret key material in the hardware. And then, like, obviously you can trivially find the private key from the public key material. Otherwise, like, if we wanted something else, then we would need to have, like, I mean, I don't know, either like a fingerprint in the secret key material, which makes no sense to me, or I don't think there's a cleaner solution than just saying, okay, if you need to find one from the other, you need to store the public key material and the secret key material together, right?
It sounds right to me.
Foco.
Not sure if I understand 100% the problem that you're all seeing, but if the problem is that, how I understand it, that if you have only the secret key on the token and you don't have anything outside, then you have no means to check whether this is the private key associated to a public key. So if you made the public key the encryption of a specific block with this private key, then you could use this to check. Not sure if this makes too much sense, but this would be the only way that I can think of how to make it verifiable whether this is the secret key to a public key.
Yeah, I think it's close to equivalent to saying something like we could store the hash of the key material or something like that. Now, maybe not quite equivalent, but maybe
because
similar.
you don't get maybe you never get the private key from the token. That's my point. So if you don't get the private key from the token, but you can still use it for an operation, for a block encryption.
Right.
So that's
the risk I see, which is admittedly a small one, is that if you have this for all keys, like if you have like a ginormous amount of keys, let's say you have a ginormous amount of AS128 keys, then you can maybe detect a collision.
Yeah,
but
it's not really scaling. That's true.
Yeah. I'm not sure it's a practical, attack, since you need to the power of 64 secret keys, but still it's like a theoretical issue.
Should be considered at least. Yeah.
At least that was kind of the reason why we originally didn't want to include the hash of the key material as well.
Maybe it's worth just explicitly writing that justification into the draft, if it's not already there. so that whoever comes after us in the various IETF archaeology can figure out why we didn't do this thing that seems like it might be useful.
Right. Should this go in security considerations or somewhere else?
I think security considerations is fine. If somebody has a better place to put it, they can suggest a better place.
Okay. Good. Thanks. Yeah, so that was mostly it. I guess the questions for the working group are we approaching, being happy with this draft, at least the proposed wire format, and also the drafts. I mean, yeah, so there was some specific concrete things which I will add. But after that, I guess similar-ish question to the PQC draft is, yeah, should we consider a working group last call maybe sometime after the PQC draft, or are there still concrete outstanding concerns? Or yeah. And then the other question is, I guess, do we need to wait for more implementation, since now we only have 2, whereas the PQC draft has 3. I don't know if our RMP is still interested in exploring implementing, or if you have any feedback as to what would make that easier. There is a test vector in the draft, so yeah, hopefully that should work well. But yeah, I guess let me know if you have any feedback or other thoughts.
Stephen's been doing time checks in the chat. We have 4 minutes left. So now is a chance to speak up. Do you have any poll you want us to put in front of the working group here?
I guess the concrete general question would be like, are we happy with it? Should we go to working group last call? I don't know if that's like a useful polling question, but.
Yeah, I wouldn't do a poll of should we go to working group last call. Like if the authors think that it's ready for working group last call, we can ask that question, and just what I would. And it sounds like you're saying you feel like it's ready for working group last call, maybe with a few minor tweaks that have come up today. We can take that question to the list. You said you'd like it to happen after the PQC working group last call, maybe just to avoid distraction. Is that the?
Yeah, I guess that would make sense. But in my mind, they sort of belong together in a way. So maybe not too long after. But yeah, I guess I will first address the points that were raised today, and then maybe mint another draft and send it to the list, and then see if there's feedback, and then we can consider a working group last call if there's no concrete issues.
Yeah, having something like having your test vectors put into the interop test suite also would be a really useful.
That is there, I believe.
Oh, it is there. Okay, great. I take it back. Thanks. I didn't realize that a change had been done. Excellent. All right.
Good, then thanks a lot.
Yeah, thank you, Daniel. If there's any other business, now is the time to bring it up. You'll have 2 minutes left. Yeah, otherwise we will see folks on the mailing list, and then there will be a meeting coming up in the. Thank you for the link to the test suite, Justus. That's great. We have a meeting scheduled for upcoming IETF 22. Stephen and I will both be remote, but we were perfectly happy to run the session from there. So be thinking about if you want to have more discussion at IETF 122, send notes to the chairs or to the list about what needs to be done. And thank you for all the progress folks are making. It's been good to see it. I think with that, we'll give you 1 minute back. Stephen, any last words?
Nothing really. No. If anybody is going to be present in person at 122, might be no harm to just let the chairs know, because we might just need somebody to sit at the front of the room and press buttons, or sit at the front of the room and be ready to press buttons if things fail.
All right.
Otherwise, thank you, and yeah, talk to you on the list.
Yep. Take care.
Bye.
Thanks, everybody. Bye.
Thank you all. Bye-bye.
Bye.
Bye.
And thanks for our note takers.
Yes, much appreciated.
Okay, DKG, do you want to hit the button to promote the notes from the thing to the thing, or do you want me to do that?
If you're up for doing that, that would be great. I'm still waking up over here.
Fair enough. Yes. Okay.
Thank you.
All right. I'll do that shortly.
Great. Appreciate it.
Cheers. Bye-bye.
Bye.